In stats, we started chapter 2. We took our test yesterday, so we are moving on. We're going to start out by talking about cumulative relative frequency and percentiles. So first off, a percentile is for any one observation and its percentile. That percentile is referring to the percent of observations smaller than the observation in question. So there's your definition at the top of the page. So in other words, like if someone is, according to GPA rank, is in the 90th percentile, that's saying that they have a higher GPA than 90% of their class. So it's the percent less, percent smaller. So in this example, our textbook looks at the first 44 presidents that we had, and it categorizes them by age, and there's our frequency. I went ahead and calculated the relative frequency. So as a reminder, you go 2 divided by the total, and that's how I got 0455. So hopefully that's review. There's a new measurement, and that's cumulative relative frequency. It's going to allow us to look at percentiles. So for example, the cumulative relative frequency up to 45 years old is exactly the same as that relative frequency printed right there. But as we move forward, you got to keep adding. So cumulative for presidents up to 50 years old, I'm going to go 0455 plus 1591, and I get 2046. And I just keep adding. I keep adding the relative frequency diagonal from it. So I add 2955, and I have 5001. I add 2727, and I get 7728. Add the next one, and I have 9319. And the last one should always add up to 1.0. I think it actually adds to 1.0001 or something like that. So there's that. Next, you make a cumulative relative frequency plot. So I'm going to write that right here. And I'm going to start making this thing, but I'm going to hit pause so you don't have to watch how tedious it is. You start out by making quadrant 1 of a graph, and you make a tick mark for each edge of the class. So I'm going to start at 40, go by 5s, and end at 70. All right, so there are our axes. I got cumulative relative frequency going on the vertical and ages on the horizontal. And now I just start making dots for each upper bound cumulative. So I do start at 0, because 0 presidents were younger than 40. And I'm going to make a dot at 0455. So you just keep making dots at each cumulative in the upper end of the class. And then you connect the dots. It asks a question at the very bottom of this screen, and it says, what does steepness tell you? Steepness means that there were a lot of occurrences in that class, if it's really steep. So if steep or steeper, then many occurrences were in that class. All right. So I would say, just looking at the plot, I'm not looking at my table, I bet this is our steepest segment. And then I cheat and I look over at my table, 50 to 55, and sure enough, that is my largest relative frequency. So that one had the most occurrences, 13. You're doing this by hand, so sometimes you might be off, but in that one, I did all right. All right, I'm going to scroll down, and then I'm going to pull this back. I'm going to get rid of my steepest, because we're going to have to make all kinds of marks on this thing. If you made a mark on yours, no big deal. But I'll pull the plot back. We ask a few questions. What percent are between 55 and 99? And also, what is the 50th percentile? So let's answer those two at the same time. One thing you're allowed to do with a cumulative plot is I can go to a percentile over here on the left, see the red mark? Make a dotted line. Now I know it's supposed to hit that dot because over in my table it says that's 5001. So then you draw a line straight down from there, and I know that 55, I'm going to have to answer these up here. So the second question that you saw just a second ago, 55 years old, is approximately the 50th percentile. Oops. If I want the percent of presidents, (55 to 99), then I take that 55 percentile, subtract from 100, and I got it. Now in this case it happens to be 50 again. So I go 50%, 50th percentile, 455. So I go 100 minus 50, which equals 50. So I would say 50% are 55, or I should say were, right? 55 to 99. All right, let's look at a couple more questions. Was Barack Obama unusually young at 47? Let's look at that. 47 is roughly right here. I would say on my plot during third period it was a touch higher. That's like the 11th or 12th percentile. So Obama was at the 12th percentile. That means 88% were older. Yeah, I think we can safely say that's unusually young. Yes, he was unusually young. I mean, it wasn't super unusual, but I mean, only 12% were younger. Let's look at another. Estimate and interpret the 65th percentile. I'm going to have to erase for this. Just a second. All right, for the 65th percentile, I need to erase a little more. I just noticed I have writing right there. Okay, now we're ready. You draw a line out, and that falls, I don't know, 57, 58. Let's go with 57. That's what I said in third period. And they say interpret. I don't know what was going through my head in third period. That was just a few minutes ago, by the way. I reread it when everyone walked out, and I was appalled. My grammar was horrible. Let's keep it simple. 65% of presidents were younger than 57. That sums it up really well. I had this long sentence, and I don't even know what I wrote on the board. It was horrible. Anyways, that's it for that plot. Let's move on. We're going to talk about standardized scores. We just introduced this, and then we stopped. So a standardized score is the number of standard deviations that observation is from the mean. And we're going to call that a z-score. When we calculate that, it's a really simple calculation. We're going to use mu for the population mean and sigma for the population standard deviation. And we'll say z equals x minus mu over sigma. Find the difference. How far away is the observation? So x is the observation. Find how far it is from the population mean. And divide by sigma, the population standard deviation. All right, we stopped there. I'll see y'all later.